Okay, so in this video, I want to start a whole new topic. These are these types of functions are called logarithms. Um, they're very helpful if you go further in math, and they're also very helpful for understanding rates of growth. So if you have calculus in your future, you will see a lot more of these. You may not if you don't, but you'll see these all over the place in uh, different science classes as well. You'll probably see these in biology, chemistry. These will show up pretty much everywhere. They're very good for dealing with growth rates, okay? So anything involving growth over time, you're going to see something doing with logarithms or exponential equations. And logarithms and exponential equations are very closely linked together, okay? So we actually have a pretty specific rule here, an equality between two different statements. So it says for numbers a, b, and c, where we have a and c, um, this should be positive. A and C, positive. Okay, and we have A not being equal to 1. We have the equivalence, okay? So when I say the equivalence, that means we can go back and forth between these two statements. If we have log base A of C is equal to B, then A to the B is equal to C. So this is phrased as log base A of C is equal to B if and only if A to the B is equal to C. Okay, and here A is the base, right? So, well, this phrase "if and only if," don't get overly confused by this. This just means we can go back and forth between these two. Okay, so if we have log base a of c is equal to b, then we can rewrite this as a to the b is equal to c. And if we have a to the b equals c, we can rewrite it as log base a of c is equal to b. That's all the if and only if is saying. So don't get too hung up on the words there. So with this information, let's see if we can rewrite the following equations. So here we have log base 5 of 1/5 is equal to -1. So if we want to rewrite this as an exponential equation, we can write this, we can first identify a, b, and c. So here, a is going to be equal to 5, all right? B is going to be equal to -1, and c is going to be equal to 1/5. Okay, so if we rewrite this, we should have a to the b is equal to c. So we have 5 to the -1 is equal to 1/5. And that is true, so we know we've done this correct. Okay, so that would be how we would rewrite this. 5 to the -1 is equal to 1/5. Okay, how about we go the other direction? We have 2 to the -5 is equal to 1 over 32. That's a true statement. So let's see if we can have the log. This is a logarithmic equation. All right, so a to the b is equal to c. So here a is going to be 2, b is equal to -5, and c is equal to 1 over 32. Okay, so with this, we can rewrite this as log base a, or base 2, of c, which is 1 over 32, is equal to -5. So again, that's true, so this would be our answer. Okay, how about this one? This one's a little interesting. Here we have log base 2 of 1 is equal to 0. Can we rewrite this as an exponential equation? Okay, so here we have if we look back at our rule here, log base a of c is equal to b. So a is going to be equal to 2. B is going to be equal to 0. And c is going to be equal to 1. Okay, so we'll have 2 to the 0 is equal to 1. That is true. So we would say that this is how we would rewrite this as an exponential equation. Okay. How about log base 3 of 1/9 is equal to -2? Okay, well here a is equal to 3, b is equal to -2, and c is equal to 1/9. So we would have a to the b is equal to c. So 3 to the -2 is equal to 1/9. So that would be correct again. So we would say this is how we would rewrite this as our exponential equation. Okay, so we have a couple of kind of weird things about logs. I'm not sure who decided this or why this was decided, but this is just a typical convention in mathematics and well, especially in the world of other sciences. People kind of forget this the further you go in math, but in other sciences, typically we have the rule where if we have a base of e, then we write ln of x, and this is ln of x is actually what we call the natural log. Okay, that's the natural log. So if we have a base of e, So if we have log base e of x, we write ln of x, or natural log of x. And then weirdly, I guess not so weirdly, this is the most commonly used one. If the base is 10, we just write log x. We just drop the base altogether. So anytime you see a log written with no base, you can assume it's a base of 10. Okay, so let's see if we can rewrite these equations using these rules here. So if we have here e to the x is equal to 5, so that means here that a is going to be equal to e, so we're going to use natural log here. B is equal to x, and c is equal to 5. Okay? All right, let me turn off my notifications here. All right, so if we have, so that means if e to the x is equal to 5, that means we can write this as log base e, or ln of um, 5 is equal to x. Okay, ln of 5 is equal to x. Okay, here we have e to the 7 is equal to x. So if we have a is equal to e, b is equal to 7, and c is equal to x, we can just then rewrite this as the natural log, or ln of x, is equal to 7. Okay, here we have 10 to the negative 1 is equal to 1/10. Okay, so if 10 to the 1 is equal to 1/10. So here, a is going to be equal to 10, b is going to be equal to -1, and c is going to be equal to 1/10. So if we have log base a, or just log here, so that's going to give us log, we go back to our rule here, log of c is equal to b. So that means log of 1/10 is equal to -1. Okay, how about log of 1,000 is equal to 3? Well, here we can actually rewrite this as log base 10 of 1,000 is equal to 3. So we can just rewrite this as 10 to the third is equal to 1,000. So we can see we can actually go back and forth between these very easily. So let's maybe make it quite a little bit harder and see if we can uh, actually solve an equation given these rules here. Okay, so here we have log base 2 of 1/16. We want to actually find out what that is. So let's just set this equal to x, and we're going to solve for x. So from this, that means we can go ahead and rewrite this as this gives us 2 to the x is equal to 1/16. Okay, so what number is going to give us 1/16 if we're raising 2 to that number? So in this case, x is going to be equal to -4. Okay, so let's look at another one here. How about log base 8 of 1/64? Okay, so again, let's set this one equal to x, and that's going to give us 8 to the x is equal to 1/64. All right, so what number is going to give us 1/64? Well, here it's going to be -2. So 8 squared is 64. So 8 to the -2 is going to give us 1/64. So x is going to be equal to -2. Okay, how about log base 8 of 1 is equal to x? Well, here we have 8 to the x is equal to 1. Well, anytime you have something, some exponential equation equal to 1, you can bet that value is going to be equal to 0. So, because anything to the 0th power is 1, so here we can just say x is equal to 0. Let's do one more. How about log of 100? Log of 100. So, we can actually rewrite this with a base 10 if it makes it easier. And we can set this equal to x. So, that's going to give us 10 to the x is equal to 100. And in this case, that means x is going to be equal to 2 because 10 squared is 100.